welcome to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. Within that, I already explained plenty of the videos on my channel. So now in my today's video, I'm going to explain to you all one of the latest question from GATE exam, which completely based on the linear algebra, that we have to play with the eigenvalue, eigenvector, and we have to find out just the easy calculations are these. Okay, very easy calculation we have to apply over here. Now let's get started on today's question. First of all, I'm going to explain to you all question and then we'll move for the detailed understanding of solution. So here in our question we have given matrix M A B C B D E C E F. Okay, the 3 by 3 matrix it is here. Be a real matrix which eigenvalue, the matrix which is having eigenvalue lambda 0, lambda 1, and lambda 1 is equal to 0, lambda 1 is equal to 1, and lambda 2 is equal to 3. So 3 eigenvalue we are having over here, and the eigenvector corresponding to this eigenvalue is given. Okay, corresponding to this eigenvector are given. For eigenvalue 1, first eigenvector 1 1 1 transpose, and with respect to eigenvalue 0 we have second eigenvector 1 minus 1 0 transpose. And then we have to find out the value for 3 times EF. Okay, and EF it is from this matrix. Okay, this one EF is there. So this is a no answer type question from GATE exam. So we have to work for the value for A, B, C, D, E, F. All value we have to find out from our matrix. Okay, and for finding the value of our matrix, we have given here the matrix M and the 3 eigenvalues and their eigenvectors. Okay, and if we know the eigenvalue, okay, if we know the eigenvalue, and using this we have to, if you wanted to find out the eigenvector, so we know that eigenvector can be written as x, which is equal to lambda into x. Okay, so x which is equal to lambda times x. So instead of A, we have matrix M. So Mx which is equal to lambda times X. Okay, and what is X? X is here the eigenvector which is given with respect to eigenvalue 0 and 1. Okay, so Mx which is equal to lambda X. So what is the value for M? Okay, M we have here A, B, C, B, D, E, C, F. Okay, A, B, C, B, D, E, C, E, F. C, E, F. Okay, and this is the value for M which is given. Okay, this one is M here. Now the eigenvalue with respect to eigenvalue 1 we have eigenvector 1 1 1. So that means, and with respect to 0 we have eigenvalue vector 1 minus 1 0. Okay, that means the value for x with respect to 1. So if I take eigenvalue lambda is equal to 1, so I'm getting its eigenvector x is a 1 1 1 transpose. Okay, and if eigenvalue if I select 0, then I'm getting its eigenvector as 1 minus 1 and 0. Okay, it's a transpose. Okay, so this is a both two eigenvector with respect to these two eigenvalue. So for eigenvalue lambda, if I consider lambda which is equal to 0, so consider lambda is a 0 first. Okay, first eigenvalue consider it is 0, and by using this eigenvalue apply the eigenvector over here with respect to matrix M. Okay, so x with respect to 0, what we have eigenvector 0 which is eigenvector minus 1 minus 1 0 to the power t, that means it is a transpose. So take the transpose, you will get the x. Okay, so here 1 minus 1 0. Okay, so what I have done, I just substitute the eigenvector over here. Okay, 1 minus 1 0 into lambda. What is the lambda here? 0. Okay, this is a 0 over here multiplied by eigenvector 1 minus 1 0. Okay, 1 minus 1 0, and we know that 0 multiplied by any matrix it will always remain 0. Okay, now find out the value for ABC by using our given data. Okay, so this is a 0, so go for the finding A into this into this plus this into this. So A into 1. Okay, so A into 1 means A plus B into minus 1 minus B plus C into 0, which will be 0, which is equal to 0. That means I got the first adjustment A which is equal to B. Okay, A which plus B, A plus minus B which is equal to 0. That's why A which is equal to B. Okay, now second B negative B plus, so we have 1 minus 1 and 0 here. So B minus D plus 0 which is equal to 0. So B minus D plus 0 which is equal to 0. So this gives B which is equal to D. Okay, This gives us B, which is equal to D. So it is easy calculations. Just we have to apply the eigenvector to our matrix and need to find out the value for A, B. Okay. So if we want the value for F, that means we want the value for A, B, C, D, E, F, all values. Because of that, because of the only other value we cannot find F. Okay. So we want all the values over here. So let's work for the A, B, C, D, E, then we'll get the F. Okay. So I got the second equation, B minus D, which is equal to 0. So 0 multiplied by 0, 0, 0. It comes total completely 0. Okay. So we'll get the 0, 0, 0 over here. Multiply here, compare here. So for finding the value of element from our matrix, we compare corresponding elements. Okay. That thing we have to do here. So B minus D, which is equal to 0. Again C minus C, which is equal to 0. Okay. Then C minus C multiplied by 1. E multiplied by minus 1. So minus E. F multiplied by 0, it becomes 0, which is equal to 0. So C minus E, which is equal to 0. Then which gives C, which is equal to E. Okay. So here we can see A, which is equal to B, B, which is equal to D, and C, which is equal to E. Okay. That means I can write A, which is equal to B, which is equal to D. Okay. These three are equal, and C, which is equal to E. Okay. Now replace these values in our matrix here. Okay. And try to find out some trace, the values from our matrix. Okay. So A replaced by only A. So B and D replace A. Okay. So we'll get the matrix. We'll get the matrix as A, B as A, B as A, D as A. Okay. So all first 2 by 2 matrix, it will come as A. Okay. So C replaced by E. So replace wherever E you found, replace C. Okay. So C is it is here, C is here, F as it is. Okay. Now, so as we have given eigen values, okay, and we know that addition of eigenvalue is a trace of matrix. Okay. So that means if we are going to add over 3 of the eigenvalues 0, 1, 3, then we'll get the trace of matrix. So what is the trace of matrix? A plus F. So trace of matrix A plus F, which is equal to addition of eigenvalue. That means lambda 1 plus lambda 2 plus lambda 3. Okay. So A plus F. That means 2A plus F, which is equal to lambda 1 plus lambda 2 plus lambda 3. That means 0 plus 1 plus 3. That means 4. Okay. So I got the first equation 2A plus 4, which is associated with the eigenvalue lambda is 0. Okay, which is associated with the eigenvalue lambda 0. Now use eigenvalue lambda is 1. Okay, so when lambda is 1, so we write eigenvector. Okay, mx, which is equal to lambda x. Okay, now so what the value for m we have to select? We have this option and this option too. Okay. So both the matrix are equal because of these values are possesses over here. Okay. This matrix possesses this value. That means this equal to this. This matrix and this matrix always equal. So instead of applying this matrix take this one. So we'll get the M as AAC, 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 AAC again, and CCF. Okay. Okay. This is the value for M. With respect to lambda is a one eigenvalue, we have eigenvector here 1, 1, 1. Okay. With respect to lambda is one eigenvalue, we have eigenvector 1, 1, 1. Okay. Here we can see that it is given in question. Okay. So apply here mx is equal to lambda x 1 multiplied by again x 1, 1, 1. Okay. Now find out the value a plus c. Okay. That means a plus c, which is equal to, compare this value 1. Again a plus c, a plus c, which is equal to, compare here. So c plus f, c plus f, which is equal to 1. Okay. So this is just a multiplication row into column and comparison between corresponding elements. Okay. So a plus a will get the 2a plus c, which is equal to 1. A plus a, 2a plus c, which is equal to 1. And c plus c, 2c plus f, which is equal to 1. Okay. So I got these 3 equation over here, this one here. And by using these 3 equation, we'll find out the value for A, B, C, D, E, F. Okay. Now apply these values here to our equation. So 2a plus f is a 4. So 2a plus f, which is equal to 4. This is the first equation we got it here. Now apply the value for 2a by using this. Okay. So how can we write 2a here? 2a, which is equal to 1 minus c. Okay. So take c here, we'll get the 1 minus c. So 1 minus c plus f, which is equal to 4. Okay, so 1 minus c into f, we got the 4. Now go for further calculation. So what, c here, take positive 1 here, it become negative, so 4 minus 1, it comes 3. So f minus c, so I got the f minus c, which is equal to 3. The value for c will get the 3, the value of a c by using this equation. Take c here and f3 here. Okay, so c, it is coming positive, and f minus 3. Okay, I got the value for c, which is a f minus 3. Now I want the value for 3 times f. 3 times f. So how can we get the 3 times f over here? So replace here 2c plus f, which is equal to 1. Instead of c, put f minus 3. Okay, so what we have here, 2c plus f. So 2 into value for c is a f minus 3 plus f, which is equal to 1. Okay, so 2f minus 2 3 are 6. 2f minus 2 3 are 6 plus f, which is equal to 1. Okay, so 2f plus f, I got the 3f, which is equal to 1 minus 6. Take it my negative 6 here, 1 plus 6, it is coming. Okay, and then I got the f, which is equal to 3f, which is equal to 1 plus 6 is a 7. Okay, so this is the exact value we want it out here. Okay, so nothing is difficult, just we have to apply the eigenvalue, eigenvector to our standard form of eigenvector. Okay, so I applied standard form of mx is equal to lambda x as eigenvector. First of all, I found this value. Then after that, this value I applied again second eigenvalue lambda 1 to our matrix, and then we got the another 3 equation. I substituted this first value over here, and then I got the value for 3f. Okay, so this one is very easier. So for your understanding and for your better information, you may see this video. Okay, so here we can see the complete solution over here for our example. So this is the example. Eigenvalue are 0 1 3 given. With respect to eigenvalue 1, eigenvector it is here. With respect to eigenvalue 0, we have eigenvector over here. Okay, so mx, which is equal to lambda x, which is the eigenvector. With respect to lambda is equal to 0 eigenvalue, we have written the mx m into x, which is equal to lambda into x. So by using this, I found out the value for a minus b, b minus d, c minus c, a b c. I got this value. I replace this value into our matrix, and by using trace of matrix, which is equal to eigen value, so I applied this one over here. So and after that, by using lambda is equal to 1, we got the second values over here. Okay, so these are the values. To a is equal to 1 minus c, trace of m is 4 is equal to 1 minus c into f. So c is equal to f minus 3, and by using these equations, I got the value for 3f is 1. So this is the required answer. Okay, I hope you all have understood my today's video. It is very easy, and just some conceptual based questions are these. So even after, if you found anything difficult, let me know in the comment section. I will come up with the same similar video on my channel. So thank you everyone. Thank you for my today's lecture.